Okay, so we looked at project 4, the assignment. Now let me walk you through what the archetype gives you. So just the same way in project 1, I gave you an archetype for getting started. Here in project 4, I gave you an archetype for getting started, and you can work from there. Oops. So let's try to copy and paste this. All this good stuff here. Airline. Yeah, that'll complain because it doesn't like all the stuff. So do what we always do, which is fix the tilde, and then fix the login ID. Yep. Okay, good, it created that. Now let's look at IntelliJ. Well, ooh, look at that. That's messed up, okay. Right. I will, let me show you how the program works, and then I will, then I'll start, I'll look at the code, and we'll figure that out. So remember I said there are two parts of the program. There's the server and the client and the server. The server is this web container that's running your web application with your servlet in it, and the web container that we're using is a web container called Jetty, which is a low footprint, easily embeddable Java web container that has a very nice Maven plugin with it. So when you say Maven Jetty run, this will build your application. So compile the source code, put together the WAR file, the web application, and deploy that to a Jetty. So as you can see, going by, it compiles a bunch of stuff. It says that yes, we are deploying the airline web application, et cetera, and it's saying, hey, I started running on port 8080, and I started the Jetty server. So over here in this terminal window, I've got the Jetty server running. I'm going to open up a new one. I'll type my very long password correctly. I'm going to go to that same directory. Let's make this guy a little shorter. There we go. So I'll go. What is that? Get. PSU get Portland State, summer 2014 airline. Does it have my jar file? No. So I've run Jetty run. Then I'm going to make my. That's not exactly the right command line. I'm going to do a Maven package to create my jar file. And I'll say java-star target airline. Oh, is the right name. .jar. So this is my client. So this runs the this runs the command. This is the command line application that will then talk to my server, and it tells me, okay, it's missing some stuff. So what I've got here is a simple program that posts key value pairs to the server. So this is not your assignment. This is some code that will hopefully help you get started with your assignment. So this works, but doesn't do what it's supposed to do. But your job is to take this as a starting point and then modify it to do what it's supposed to do. But I think it gives you all of the pieces parts that you need. So what does it do? It takes 4 command line arguments, a host, a port, and like keys and values. So it's basically storing a map on the server. So the host is going to be localhost. Right now refers to this machine, the one that's running on. The port is going to be 8080 because, like as you can see right here, your Jetty is running on 8080. And then I'm going to say, hey, a key. Is there a value for, well, name, what would be some, anyway. So as an example, I'm going to put a key of the number 1 and then the word 1. So when I run this command line, it tells me that it mapped 1 to 1. And now when I go to query that, if I just put in the key, it'll ask the server, hey, is there a value? It says yes, the server contains 1 key value pairs. Or maybe just print them all. 1, 1. So if I then put 2, what does it say? Okay, it tells me that yes, there were no key value pairs that match that, and that 2 went to null. I guess what I don't see, maybe I should change it so that it prints out something over here, so that we can definitely, so that we can see that something's actually happening. Maybe we should go do that right now. So I'm going to go to IntelliJ. I'm going to import a new project from that guy. So not my check kata, but let me refresh. My airline. Go through our old friend here. Yeah, all that good stuff. I don't need that. Sure, let's use that. Java 1.8 because it's the future. Airline. Okay. Okay. So well, I guess let me do a check here. Do you understand what's happening? We've got 2 programs running. One is your server, one is your client. Your client runs and exits. Your server stays up and is doing things. Okay? Got that much? Okay. Oh my gosh, what does the source code for this look like? You'll see more examples of this in the screencast, but there's a bunch of stuff here. There's something called the web.xml, and I don't know whether or not you're going to modify this or not. This is the thing that configures, that basically tells Jetty, hey, when you see a URL that starts with /flights, route it to the airline servlet class. As a matter of fact, let's do something else. Let's also hit this guy, localhost 8080. What was that thing called? I think it's called /airline/flights. Yep. So when I hit that URL in the web browser, I get the same thing that, oops. Actually, if I just do that, oh yeah, it tells me it's got two key value pairs. So I put 2 and 2. So I hit with 0 arguments. It basically hits this URL. And I think the way it works is that if I say key equals 1, no, bad example, key equals 2, yeah, it does that. So the command line program is doing is sending these URLs to the server the same way that the browser is. Okay? So it's almost like you're writing computer programs. Okay. Right, let's look at the code. So there's like this configuration file, which I think is good enough for the project. And what's really interesting is then the code itself. So on the server side, you have something called the airline servlet. This extends HTTP servlet, which is that standard API that interacts with these web requests through the web container. Blah, 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 blah. So one of the things to learn about in the screencast is that there are different verbs associated with HTTP, like get and post and delete. For each one of those verbs, there is a method of HTTP servlet you can override. So you can say like do get. The do get has 2 parameters, one that represents the request coming in from the client, and the other one which represents the response going back to the client. So what this code does right here is that it says, okay, when there is a get request, so when a client makes a HTTP get request of a URL that gets routed back to this servlet, this Java code is run. And what does it do? It says, okay, well, hey, I'm going to set the content type for the response, meaning I'm sending back to the client some plain text. And what am I going to do? I'm going to look to see if there's a parameter called key that came in on that URL. on that request. If it's not null, then I'll call this write value. Otherwise, I'll write all of the mappings off to the response. This is just Java code, right? And so what does write value do? Well, it says, okay, here's the key and here's the response. It goes and looks in this.data, which is simply just a hash map, it's a map. And it goes and gets the value and then gets a print writer. You guys remember print writer from the Java I/O lecture? So here we have like this magical HTTP object that represents the response. But when you want to say, hey, I just want to write some text to that response, the API reuses this print writer that everybody's familiar with to give you the ability to do a print line of something that ends up going back to the HTTP client. So anyway, so then I've just got some stuff being written here. And by the way, and then you also, once it's written and everything, you you set the status to be like HTTP 200, so that yes, it means everything's going well. Understands what's happening here? So here I've got some code that sort of like lives in this magic bubble of the web container. Somebody else, who's much smarter than anybody in this room, wrote all that code around it to take the HTTP request, listen for the HTTP request, and translate it then into a call and do all the right routing to one of these do get or do post methods, and then just execute the Java code. So really, it's like this is the logic of your application. This is the interesting stuff to you right here. And what you're doing is by putting this logic, by making this logic accessible by a servlet, you can now easily plug that into this web container and then start up the web container and have web clients talk to it. Okay. This is the server side, and like I said, this is very simple stuff. This is the whole idea is that I'd like you to use this code to sort of figure out how your client and your server talk to each other. Oh, I guess then by the way, I wanted to add some debug output. So I think like what I'll do here is I'll just add a system.out.println. Oh, why do I have? Oops. I have 4 space indents in this code for some reason. Let's see here. Writing value key to client, or sending value. Sending the value for key to client. I'm going to stop my server, and notice now if I try to ping it again, I get a right. Can't do that. I'll run Jetty again. This will recompile my code. Start up Jetty again, and actually I'll run this command line here. One. Now when I do that, I get my output. Send the value 1 to the client. Hasn't been mapped yet. Do it again. Now now it's got a value. So that's the server side. So when you implement the server side of Project 4, you'll need to implement your own, change what the do get and the do post methods do to interact with your airline code instead. And I encourage you to make use of methods like this get parameter and stuff like that. Okay. That is the server side of your program. And now let's take a look at the client side. So here's your Project 4 main. And right there were, so this command line is simple. It only takes like these 4 command line arguments, although by now you guys should all be experts in parsing the command line. Put that one on your LinkedIn profile. So we go through and think if anything's interesting. So this is all command line parsing here. The real work comes in this airline REST client. So this is another class that that interacts, that is the client to the REST API that makes the calls to the server. And you create it with the host and the port. And I've implemented some functionality on it. So for instance, hey, listen, if the user didn't specify a key, then call the get all keys and values method of the client. So what does this thing do? Oh yeah, okay, so then this is a kind of a thin wrapper around a class that I wrote called HTTP request helper, which, well, we'll come to that back in a minute. Okay, so it provides methods like get a URL or post to a URL with these key value pairs, or get it for a URL with these key value pairs. This is a pretty sure this is variable arguments. Yep. Okay then. So URL is well, the URL that you hit. And so let's see what the get method does. This is where things get a little bit more complex. And here I think I want you to understand what this code does. I think you should be able to leverage it though to do what you need to do. So this code simplifies. This code is the thing that actually makes the connection to the server and then and interacts with it. And it uses standard Java classes like JavaNet URL and HTTP URL connection. You'll learn about all of these in the screencast. So what does it do? It creates one of these URL objects. So this is an object that represents some URL. Okay, open up a connection to that URL. Tell it that I'm doing a get. Say yes, I want input and output, and then I create this response object. Which, you know, I'm not going to go into much detail here. I want you so you guys can figure it out on your own. But anyway, it's covered in the screencast. The whole idea is that this class wraps all of the low-level interaction for interacting with URLs in Java. And I recommend that you use it and that you take a little bit of time to understand what it does, at least enough time so that if you run into a problem, you can debug it. And I think not only does this make your life easier, but it also provides a nice abstraction over what it is that we're trying to do in this assignment. I want to pause for questions again. Yes, Blake.
Is there a formal definition for servlet? Can you define that?
Sure. Formal definition for servlet. I'll tell you how I think about it. And here again, I think I probably explain it better in the screencast because I got some pictures and stuff like that. Talk about programming to the interface. What the servlet API does is it provides a contract between your code and the web container. So the web container does all sorts of heavy lifting. The web container, what it knows about is HTTP. It knows how to consume an HTTP request. It knows how to turn it into objects that the servlet API understands, and it knows how to take objects from the servlet API and turn it back into HTTP. Right? Because the client, so your web browser just knows HTTP. It doesn't know anything about Java, right? So your browser's not written in Java, most likely, right? What they talk is HTTP. So the contract between the client and the server is HTTP. Similarly, there's a contract between the web container, which is all an expert in HTTP, and then your code, which is an expert in, well, airlines and flights. There is an interface, a contract between those two, and that's the servlet API. And so that's things like the do get method and the HTTP servlet request object. I'll go into more details about this in the lecture in the screencast. But here are the Java docs for HTTP servlet request. So there is this API. There's this object here that your code can use and get all sorts of information about the request. You can get the cookies and get headers associated with it. It can you can say, hey, here's the query string that was there as part of the URL. Here's information if you're authenticated about the user who's making this request. All that information is contained in the HTTP protocol, right, or HTTPS and stuff on top of it. Blah blah blah. It's all been abstracted out to you into a Java API because what you know and what you want to write is Java. not have to understand all the low-level details of the HTTP protocol. So, right, so you understand what the value of this is then? It lets you focus on writing your application in Java, and you only need to worry about these abstractions. You don't need to worry about what's happening like on the wire and stuff like that. Yeah. Good deal. Experience has shown that this assignment can be a lot of fun, but it's something different, I think, than a lot of you have done before, and so then expect it to be challenging in places. And as always, as you encounter questions, please post to the Google Plus community. It's due in 2 weeks. Any other questions? No? Okay. Awesome. I'd like to dedicate the rest of class to doing a code kata. So last week we did a simple FizzBuzz kata. I chose another kata for us to practice on this week for translating numbers into Roman numerals. So I'm not going to read this whole thing. You can. It's also linked here from the home page. I have all of the USB keyboards. If you'd like to use that to pair, I recommend again that you pair, and I suggest that you pair with someone who you didn't pair with last week. And if someone would like to pair with me, I'm going to be doing it too. So that's an option. So let's start that. I'll get out the keyboards, and we'll work on this for a little while, and then we'll do that Google Hangout thing again where we share our desktops and talk about what we're doing. Anyway, let's go. Okay. Let's open up a Hangout. Start a video Hangout. Join the Hangout. Here's the command line for a new project from the Maven archetype. Let me find, just use the student one. Yep, student is way up here. Control. Yeah. Alt-C. That take? No. Using the silly keyboard. You know what? No one else is doing it. I'm not going to do it. Okay. Oops. Copy this. Archetype. There we go. We'll fix that for them. Yeah, it's me. Turn off my camera. There. Okay, guys, I just posted to the community, and that should have the Maven archetype. So if everybody can check that out, join the Hangout. Okay. So let's see here. Control C this. Do this instead of student archetype. We'll just call it. Oh wait, that's not right. Control C. Oops, what doesn't it like? Oh yeah, right. Doesn't like the quote. Come on, you can do it. Control C. There we go. Okay, edu, pdx, csv, j, look, artifact ID, Roman numeral, kata. Oops. No roles, kata. Version that, package that. Sounds good. Roman numerals, kata. Let's get add this. Get status. Oh, yeah, right. Get status dot. Get commit. Should do that. Okay, so then added files from student archetype to get started with Roman numerals kata. Get push. Okay, so now let's go open up the project. Close out this dude. We'll import a new project. We'll have it. Let's refresh again. Roman numerals kata is already there. Super nice. It's Maven. All this good stuff. Java 8. Okay. Student test. So I don't need all of this stuff. I'll just rename these. I don't know. I think I should call it Roman numerals test. So let's see here. Rename Roman numerals test. Yeah, I don't think I need to invoke main test case. Yeah, I don't want any of this stuff. And then student. Oh wow. Don't want any of this. I want Roman numerals. And oops. Yeah, go ahead. And really, none of this stuff is important. I probably need a better archetype in this. Okay. Okay, let's go back to the kata, see where we're at. Romans were a clever bunch. Uses I, VX, L, C, D, M. C is 100, D is 500, M is 1,000. Convert normal numbers to Arabic numbers to Roman numerals like that. Note that you can't write numerals like IM for 999. Modern Roman numerals are written by expressing each digit separately, starting from the leftmost digit and skipping any digit with a value of 0. So, example 1900. 1900 is 1000 M, 900 CM, 90 XC, resulting in that. 2008 is 2008. So MM, so no hundreds, no tens, but ones. Interesting. Okay. So, clues, because I think I need one. You made the code really beautiful and highly readable. Can I derive one using strict TDD? That's what I'm going to try. Does the order of the test affect the algorithm? We're going to work on the algorithm first before starting with TDD. In this case, it might be. Best data structures, CSV file, use fit. Oh, I forgot all that. Okay, so 1999. Oh, okay. Okay, well let's see what we got here. Okay, so test. Oops. It's messed up. Import class there. So public void Roman numeral for 1 is I. assert that static import from Hamcrest. So Roman numerals dot Roman numeral for 1 is 1. Yeah.
We're running into a challenge. We tried to basically just create another class inside of this.
Mhm.
And I'm assuming somewhere within the span of time, I've updated some stuff because it gives us.
Oh yeah, class supported. Yeah, so let's see. That's Java 7. It looks like you can be running with JDK 8.
Okay.
So then you can do that with.
Auto settings.
Yeah. Give that a try after we load the project. Looks like you got it. How interesting. Is that going? Okay.
Okay.
Cool. Yep. Okay. So return. Yeah, actually, return null I think was fine. Okay. Oh, assert that equal to static import method from this matter. Okay. Cool. Let's. Oh, Maven project need to be imported. I don't know what that is. Oh, and also I need to enable version control integration with Git. Quick changes. There it is. Oh, I've got a bunch of stuff from my. Just gonna see here. Let's move all of this other stuff off to a different change set just so it's out of my face. Other stuff. Oh, I made the default change list? No. No, I'm getting stuff from other people talking. I'm going to mute that. Cool. Okay. So let's see here. I'll make that default. Set active change list. Is that what it does? There you go. No, I have to remove those. So I remove these 3 off to other stuff. Yay! Okay, now I've got something I care about in numeral katas. What did I change in POM? Oh, because I renamed that. Okay, that's nice. Okay, so first unit test. I will run it. Okay, expected I, but was null. Okay, so let's see here. So, return I. Okay, that's good. So, I'll commit these 3. No, I want to commit all 3 of them. And, yep. So, got first test to pass. Push. Push to origin master. Sure, that's good. Okay. Oh. Apparently those aren't in GitHub, so I'm going to add those. I guess I wasn't smart enough when I renamed it to add the new ones. Right, that's all the airline stuff. Not so interesting. Yeah, those are their stuff. Okay, so I'm going to commit those 2 again. Same method. No errors and one warning. What's the one warning? Oh, parameter numbers you never use. Yep, that's probably what I should have expected. And yep, couldn't push again. Okay, so duplicate this for 2 II, and for 2 is 2 equal to II. Let's try this one again. Let's do all of them, let's do the 1. No, let's do the 1. Run this one. Right. So let's see here. So let's do a switch. Well, I could do something like string builder. SP equals to string builder. And then what? 4 int I equals 1 while I less than or equal to number I plus plus SB dot append. What is it? I. So I'll also get 3, but I won't get 4. And then return SB.2 string. Yeah. Do you want assert equals or do you want to assert that? Assert can get both? Yep, totally. So yeah, from assert equals you want org jQuery. You'll want the one from Hamcrest. Oops. Yes, I did. This is why I wish I had a partner. No one wants to pair with me. I'm lonely. Oh well. Okay, so then if I run everybody, okay, so now if I go and duplicate this one for 3, oops, for 3 is I. Computer's running kind of slow. I bet it's because of that Google Hangout. Shoot, do I have? No, it's running not that much. Here. Okay. Oops. Okay, and run it. Okay, so now 4, this one should fail. 4 should be IB. So run that one. Yep. So now, okay, so now I kind of want to take a step back and really think about the algorithm, because I think just doing this sort of like trying to do it piece by piece probably isn't going to work very well. It doesn't mean I can't have test-driven development, though, or at least I can't write the test first. So I think I'm going to go, well, let's see here. You know what, I should have committed before this one. Because that'll give me a checkpoint to go back to. So these all pass, right? Go and run that. Yep, everybody passes there. So then we'll look at changes. And we'll say that one's like that. Next change. Oops. Yeah. And then that is added those two. Yep. So let's see here. Roman numerals for 2 and 3. Okay, so I think what I'm going to do is I'm going to change all these. I'm going to say Roman numerals from 1 to 10. And here's what I'm just going to do. I'm going to like just do a whole bunch here, which, I don't know. It'll just be easier to read if I combine them all. Maybe it's not the best form, but I'll be able to deal with it much easier. Oops, get the wrong line. 2, 3, 4. 2, 3, 4. 2 equals 2 bi. So actually, let's not do this one yet. Let's get these ones to pass. Okay, let's commit it. Refactor test to do numbers 1 through 10, which I guess doesn't really do it, only does 1 through 3. Let's commit it, we won't patch it. We won't push it. Okay, so let's see here. So now 4 is IV, 5 is V, 6 is VI. Let's see here, 7 is VII, 8 is VII, 9 equals IX, and 10 equals X. Okay, let me think about the algorithm here. So like if you are 1 less than like one of them, like a 5 or a 10, they subtract 1. Otherwise, it's like the previous one and then 1 to 3. So I wonder if that's like the algorithm I should use for like 1 to 10. So if like it's 10, it's X. If it's 1 less than 10, so yeah, if it's 1 less than 10 or 1 less than 5, it's like the difference between the two followed by that. Here is the difference between 9 and 10 there. And I think it gets weirder afterwards. So let's see here. I think we need to use like an integer divide. I need a piece of paper to write on is what I need. I've got a whiteboard. Okay, math. So let's see here. So if I run this, yep, fails on 4. Okay, so like oops. So if like number equals 5 minus 1. Oops, assignment. Come on, Dave. equals 5 minus 1. Then we say like sb.append I and sb.append. Give it a minute. And b.
And I'm running a plugin that tells me.
So let's see here. Okay. So let's see here, what do I want to do? So what I want to do is I want to pause and think about this for a second. Okay, let me, I don't know, I'm just messing around now. Create method here. Something tells me that I want to be recursive about this. Okay, so I really want the logic back in here. So I want to say, listen, if the number is greater than 5, append v, and then say Roman numeral 4. Oh, right, yeah. Roman numeral 4, the number minus 5 string buffer. Else is less than 5. Else if number equals 4. Wait, do I have a special case 4? And vi. Else assert that number is less than 4. And then I want this. There's greater than 5, blah. And that'll get like, I think that'll get a bunch of them. Gosh, I don't know, I'm kind of missing it as I go along. But I'm writing tests, so at least I'll know what works, what doesn't. IV, but was VI. Oh, which one's that one? 4. Oh, I think I messed that up. Equals 4, yeah. V. Okay, excellent. Oh, it could be 5, but... Oh! I want to say a bit greater than or equal to 5. Oh wow, and that worked all the way up to 9. Okay. So maybe I am making some progress here. So I say if number greater or equal to 10, so do an else if append x and then Roman numeral 4, number -10, must be, I want 9 again. It seems so weird to have to like special case else if number equals 9. There's got to be a better way to do this. SP dot append. Yeah. IX. That's so gross. Wow, that worked. But boy, is that going to scale? Well, we'll find out. That's kind of an awkward algorithm right there. Okay, I am going to commit this. Yeah, it's so gross. And then think about refactoring it, I think, as things grow. Okay. 1 to 10 torque. Well, sure, I'm happy with the algorithm. Okay. Well, let me go get the Google Hangout going again here. I'll pause this, which I'll just stop now, and then we'll do the group work.